Hello students, we are going to go over your section 5.1 homework. Follow along with a different colored pen and make corrections as you go. This is a really big part of learning, being able to see what you did right, what you did wrong, and be able to ask for help if you still don't understand. So, on number 1, tell whether the ordered pair is a solution to the system. All right, so I'm going to plug into both equations, x for 2 and 2 for x and 6 for y, to see if I get a true statement. Remember, in order for something to be a solution to the system, it needs to be a solution to both equations. So I've got a blue equation and a red equation. All right, so let's check for this blue equation first. X is 2 plus y is 6 equals 8. And I like to put a question mark because I'm not sure yet, but I simplified down and I do get a true statement, 8 equals 8. Let's check for the red equation. 3 times x, which is 2, minus y, which is 6, equals 0. Is that true? I don't know. Let's simplify. 3 times 2 is 6, minus 6 equals 0. 0 does equal 0. That's true. So I can conclude that 2, 6 is a solution to the system. Nice. And you want to show your work all the way through, just like me. Number 2. Let's do this again. Kind of the same situation. I'm going to plug in negative 2 for x and 1 for y. I've got a blue equation and I've got a red equation to kind of keep things straight. All right, so 6 times x, which is going to be negative 2, plus 5 times y, which is 1, equals negative 7. Not quite sure yet. 6 times negative 2 is 12, plus 5 times 1 is 5, equals negative 7. And negative 12 plus 5 is negative 7. So yeah, that works out. But I need it to be true for both. So let me check my red equation. 2 times x, which is negative 2, minus 4 times y, which is 1. Does that equal negative 8? 2 times negative 2 is negative 4, minus 4 equals negative 8. And negative 4 plus negative 4 is negative 8 equals negative 8. That's true. So I can conclude that negative 2, 1 is a solution to the system. Nice. All right, down here, use the graph to find the solution to the system of linear equations and then check. So we're kind of doing exactly the same thing that we did above, except for instead of being given the point, we have to go find it on the graph. So remember, that solution is where those two lines intersect. So my solution is right here at negative 4, 5. So negative 4, 5. And I want to check if that's true because, it's hard to tell on a graph. It may not be 100% accurate depending on how you draw your lines. So it's always a good idea to check. I'm going to plug in negative 4 for x and 5 for y. I've got two equations. I've got a blue equation and I've got a red equation. I'll plug everything in. All right, 6 times y. Y is 5 plus 3 times x. X is negative 4 equals 18. I don't know. 6 times 5 is 30 minus 12. Simplify further. 18 equals 18. Yeah. Works out for the blue one. Let's check for the red one. Negative x, which is negative 4, plus 4 times y, which is 5, equals 24. This is a positive 4 plus 20 equals 24. And after I simplify further, 24 does equal 24. So I just checked and verified that negative 4, 5 is a solution to the system. All right. Moving right along here. Problem number 4, we're going to graph these things, and we're happy because they're already both in slope-intercept form. So I've got a blue equation, and I've got a red equation. Here we go. My blue equation, I start off at my y-intercept of positive 2. And I have a slope of 1 over 3, which means up 1 and then right 3. So going up 1, right 3, up 1, right 3, and down 1, left 3, down 1, left 3. You want to extend across your graph. And make sure you either color code your lines or you label them, so I know which line is which. For my red equation, I have a y-intercept of 5, so I'm going to start off at positive 5. I got a slope of 2 over 3, so that means I'm going up 2 and right 3. I have not enough room up here, so I'm going to go the opposite direction, which means down 2 and left 3. Down 2 and left 3. Okay, and we actually don't have enough room on this graph, so we're going to just extend the number line a little bit further, and then we'll just be careful and follow the pattern still. So we're going down 2 and over 3, and we should be at negative 9, negative 1. And we can do the same for the blue line. I'll just extend it a little bit further. We didn't know that earlier. Down 1 over 3, and we get that intersection point right there. Okay, so let's connect these lines as accurately as possible. Oops. And this might be a little bit rough because we have to extend on our own, but that's okay. And we got a solution right here at negative 9, negative 1. So we can plug this back into our equation. X is negative 9, y as negative 1. Let's go ahead and do that. Into our blue equation, we've got negative 1 equals 1 over 3 times negative 9 over 1 plus 2. Negative 1 equals negative 9 over 3 plus 2. And negative 9 divided by 3 is a negative 3 plus 2, which is a negative 1 equals negative 1. So it works for that blue one. And we're a little concerned because we had to estimate, so we want to make sure. We had to extend our graph on our own. We want to be positive. All right, for the red equation, I've got y equals negative 1 is y, 2 over 3 times x, which is a negative 9 over 1 plus 5. All right, is this true? Negative 1 equals 2 times negative 9 is negative 18 over 3 plus 5. And negative 18 divided by 3 happens to be negative 6 plus 5. And negative 6 plus 5 is negative 1. So we did a good job, even with some weird circumstances, and got our solution, negative 9, negative 1. Okay, let's move on to our next example. Or not example, but homework problem. I've got two equations. I got a blue one, and I've got my red one. These are not in slope-intercept form, so I need to get them into slope-intercept form in order for me to graph them. I'm going to take my blue equation down here. X minus 4y equals negative 4. And I'm going to solve for y by subtracting x to both sides. And I'll get negative 4y equals negative x minus 4. And then I'm going to divide by negative 4 everywhere. Make sure you divide every single term. My end result will be y equals 1 over 4x plus 1. Remember with graphing, we love fractions. It's just rise over run, so no need to simplify into a decimal. All right, my second equation, my red one, I need to solve for y also, so I'm going to bring it down here. I need y by itself, so I'm going to add 3x to both sides. And I'll be left with negative 4y equals 3x plus 12. I'm going to divide every single term by negative 4. And you'll have y equals negative 3 over 4x minus 3. All right, let's get to plotting. My blue equation, I'm starting off at 1, and I've got a slope of up 1 over 4. And I can also go down 1, left 4. And do your best to accurately connect these points as best you can. My red line, I have a y-intercept of negative 3 and a slope of down 3, right 4, but I can also go up 3, left 4, and I can already see where my intersection point is. Connect as accurately as possible. And my solution is right here at negative 4 over 1, not 1, 0 up. Okay, and I want to check. So let's check. I'm going to plug in negative 4 for x and 0 for y. Now I'm going to come check over here. I'm going to just make a little distinction. This is where my check is happening. I'm going to check my blue equation first. Negative 4 for x, 0 for y. So I've got negative 4 minus 4 times 0 equals negative 4. Negative 4 minus 0 equals negative 4. Sure enough, that's true. I'm going to check my red equation. All right, negative 3 times x, which is negative 4, minus 4 times y, which is 0, equals 12. Negative 3 times negative 4 is 12, minus 0 equals 12. 12 does equal 12. So I've checked, and that answer is 100% correct and true. Down here, describe and correct the error. The solution of the system of linear equations is 3, negative 1. All right, well, it looks like it's 3, negative 1. Everything seems okay. So let's check. Okay, let's check. So I'm going to plug in x and y. I've got a blue equation right here. Let's check if that's true. X is 3 minus 3 times y is negative 1 equals 6. All right, negative 3 times negative 1 is a positive 3. That's true. Let's check our other equation. Two times x is 3 minus 3 times y is negative 1 equals 3. 2 times 3 is 6. And negative 3 times negative 1 is a positive 3 equals 3. 9 equals 3? No, that is not true, okay? So we did not get a true statement. So 3, negative 1 is not a solution. We need a true statement for both, Okay, it has to work for both, not just one. Number 6, is it possible for two numbers to exist such that they have the sum of 1 and a difference of 6? All right, I don't know what those two numbers are, so naturally I'm going to use x and y. So they have a sum of 1. So the two numbers I have add to 1. That was supposed to be y, my bad. And a difference of 6. All right, well, let's see. Let me graph these things. Negative x, I get y equals negative x plus 1. And then over here, let me solve for y. Negative x, negative y equals negative x plus 6. I'm going to divide by negative 1 everywhere. Y equals x minus 6. Let's graph these things. First one, I start off at positive 1 with a negative slope. There we go. I didn't like that. Let me fix that connection. You want to be as accurate as possible. It's rough, but all right, it'll do. We can work with it. And negative x minus 6, we start off at negative 1, 2, 3, 4, 5, 6. Now we're going up and over. All right, and I kind of notice as I'm doing this that the blue line passes the red line and they don't intersect perfectly. They don't share a point. They're kind of in between boxes. So that tells me that there's no solution that is solid, okay? So is it possible for me to have two whole numbers that demonstrate the following properties? No, okay? It is not. I can't have two numbers that have a sum of 1 and a difference of 6, okay? These lines do not intersect perfectly. These two lines do not intersect at a whole number or coordinate, so the criteria is not met. All right. Tricky, but doable. Number 7, this is a really important problem. You're going to get so many like these. You have to know how to deal with these. ASB sold CHS shirts for $5 each and CHS hats for $10 each. They sold 30 pieces of gear and made $200. Write two equations that represent the situation. All right, it's important to understand what our variables mean. X is the number of shirts sold. And we can actually label our x-axis that too. And Y is the number of hats sold. Okay, so I have two pieces of information here. I've got ASB sold these shirts for $5 and hats for $10, and they made $200. So this equation, I can say I sold shirts for $5 each and hats for $10 each, and I made $200. My second piece of information is they sold 30 pieces of gear. So that means however many hats I sold, or shirts I sold, plus however many hats I sold, is equal to 30 pieces of gear. All right, let's solve these so that we can graph them. Y equals negative x plus 30. There's one equation. In the other equation, I'm going to subtract 5x from each side. I'll get 10y equals negative 5x plus 200. And I'll divide by 10. Y equals, it might actually help us to keep negative 5 over 10 instead of 1/2 for this example. There's my second. All right, I am going to go by 5s over here on my graph. And 10, 20, 30, 40, 50. Green equation first. We're starting out at a positive 20, and we're going down 5 over 10. This is why it's kind of helpful to use 5s and 10s rather than 1 over 2. This is something you might realize as you go along. You're like, oh, 1 over 2 is kind of small. I'm not going to see a 1 over 2, but I can use common denominators to help me. In my blue equation, I'm starting at a positive 30, and negative x is the same as 1 over 1, which is the same as 10 over 10. So I can go down 10 over 10, down 10 over 10, down 10 over 10. Try to use some fraction knowledge here to help you out. Ew. Connect as accurately as possible. And there's my solution right there. 2010. So, given those two criteria, that I sold 30 pieces of gear and made $200, I can conclude that I sold 20 shirts and 10 hats. Really important that you always draw your conclusion in context. All right, you guys, I really hope that you took the time to go over your homework carefully. This is very, very imperative to your success. Making sure that you check over your homework, make corrections, and then ask questions where you need help and you need them. Hope you guys have a wonderful day.